Good morning and hi everyone. We are from Group 7 Mokinje. We'll be presenting our device, which is the straw filter. Our group consists of 4 members, which is Chong Li Hui, Shamimi Usna, Shahira, and also me, myself, Ranjini Ratira. Our group selected product is straw filter. Straw filter is known as a device that applies a concept of purification of source water by filtering the sediments, impurities, bacteria, and viruses to convert the source water to drinkable water. Market and demand of water purifier. The global market for water purifier was reportedly valued at USD 36.02 billion in 2020 and is expected to rise to 107.25 USD billion by 2030 with a CAGR of 11.9%. Meanwhile, in Malaysia, the water purifiers market was valued at USD 353.20 million in 2020 and is projected to achieve USD 653.10 million by 2026.
Next is market survey. So based on the targeted consumers, they are expecting the straw filter to turn the source water to drinkable water that is clean and no impurities available. Besides that, the straw also should be small, lightweight, and portable, making it convenient to carry it around. As we propose 3 stages of filtration and utilize BPA-free materials, the straw should be able to remove sediments and impurities, reduce the water turbidity, and single-use plastic usage. Besides, the straw can be recycled upon the end of its lifespan. For the safety needs, it is important to ensure that the straw is free of harmful materials and the filtered water is safe to be drunk and not affect the consumer's health, as well as the contaminants will not affect the filtration system. Innovation map. From this figure, the basic layer consists of the straws, body materials, and the filtration system, which are the pre-filtration and ultra-filtration. So this process or manufacturing technologies comprises of various types of materials. For instance, the body and packaging of the straw, the material used are ABS, plastic, and food-grade polypropylene, whereas the filtration system are consisting of coarse filter screen and medical-grade PP cotton, whereby both materials will involve in the pre-filtration process. For the ultrafiltration process, hollow fiber membrane to be used with pore size of 0.1 micron diameter. The materials introduced determine the technical qualities of the straw filter, such as ABS, plastic, and food-grade PP, helps to achieve the durability and desired weight of the product. Type of the membrane implemented will affect the flux and membrane falling, while the pore size of the membrane will influence the efficiency of the filtration process. Therefore, the ideal materials utilized in developing the straw filter determines the technical attributes of the product. Hence, it will help in achieving the customer value proposition as shown in this figure. As 3 filtration stages are implemented, the straw filter will be able to remove the contaminants up to 99.9% with log reduction as shown in table 1. So the pore size of the filter is 0.1 micron diameter and the straw filter is expected to have lifetime of 4,000 liters, beside no external equipment needed when using the straw. Next, mathematical model. For percent removal of contaminants and log removal, it can be calculated as the formula shows here based on the parameters of the organisms in the source water as in table 2. So based on the calculation, it can be concluded that the straw is able to remove and exceed the requirement of the log removal in the water. So the straw filter is expected to have a very minimal number of contaminants present to ensure the water is safe to be drunk. Hence, the exposure to the contaminants in the water can be calculated based on the information in table 2. So EPA has regulated the specific rules of the safe drinking water, and it is noted that the amount of organisms in the filtered water are supposed to be 0. However, in the aspect of ultrafiltration, the process can remove at least 99% of the contaminants. So based on the calculation here, straw has successfully proved the efficiency of its filtration system due to the reduction in the exposure of the contaminants. The risk of infection is calculated to measure the possibility of the end users to be infected from the filtered water. So based on the calculation here, the possibility for the straw filter user to be infected by the microorganism is nearly 0, which corresponds to the amount of exposure to the contaminants in the previous slide. Straw filter does not require any external equipment to suck the water into the straw, as it only requires the user to use their mouth. So based on the air pressure formula and the mechanism of the straw filter that is similar to the normal drinking straw, the maximum height of the water can be sucked through a straw is 10.33 meter. However, the design straw filter's height is 170.2 millimeter. So this proves that the straw filter operates at the same way as the normal drinking straw, which involves the atmospheric pressure and suction action from the user's mouth only.
Next is the design selection of the straw filter. The selection of material to design the straw filter is crucial as the device is expected to be lightweight and portable. Few considerations have been taken before selecting the best material for this filter straw, such as the durability of the material and the safety hazard for it. First is the ABS plastic. It is selected to be used as the outer layer of the straw filter to increase the durability of the device. Next is the food grade polypropylene, which has low water absorption, making it an excellent choice as a raw material for straw manufacturing. Next is the coarse filter screen, which is added as a pre-treatment process to help to remove the big contaminants such as solids and rocks. Then we have hollow fiber ultrafiltration membrane, which is to remove 99.99% of bacteria, microplastics, and protozoa. Lastly is the medical grade PP, which is proven to reduce the water turbidity of water more efficiently compared to the normal PP cotton fiber. Lastly, as for the color, which is cyan, as it is more nice and more attractive. The dimensions of the straw is carefully decided to ensure it can function well to fulfill the product performance requirements. This is a different view of filter screen. The left one is the from top view, the middle one is from the front view, and the last one is from the side view. Lastly, this is the 3D model of our straw filter.
Next, I'll talk about the economic analysis. Next, I'll talk about the unit price of the straw material. The unit selling price of the straw material is decided based on the current market survey that I've done on the raw material use from different company. And the prices of the raw materials will be calculated and discussed on the following slide. Before that, there are a few assumptions that have been made throughout the calculation. Firstly, it is estimated that the currency exchange rate between the US dollar and the Malaysian ringgit is 1 USD to 4 ringgit and 18 cents of Malaysian ringgit. And also, the unit per purchase of the raw materials is assumed to be as below so that we can get a cheaper price as we are purchasing in a bundle. The straw filter consists of three main components. The first one is the filtration membrane, which uses the hollow fiber UF membrane, which is specified to 0.1 micrometer, using it to remove the bacteria and also a virus. Another one is medical grade PP cotton to reduce the turbidity of the water, and also lastly the coarse filter screen to remove big particles like sands and also rocks. And the prices per unit are calculated as shown as the table below. The second and third components are the outer layer cast and also the straws, and the price per unit were calculated of the raw materials were calculated as the table as shown. The cost for raw materials for producing 1 unit of straw filter is 21 ringgit and 35 cents, and also another 100% of price is expected to cover up the expenses such as packaging costs, shipping costs, and utilities. Therefore, we can conclude that 1 unit of straw filter will be selling at 42 ringgit and 70 cents. And comparing to the prices of our competitors, we can conclude that our product will have a very high demand in the market and is cheaper in price. The assumption made to calculate the investor rate of return are shown as below. Firstly, the depreciation and book value calculation is done referring to the MACRS tax basis table, and the depreciation is calculated by multiplying the tax basis with the equipment cost, and then the book value is calculated by subtracting the equipment cost with the depreciation. This table shows how IRR is calculated by entering the value, and also the red color meaning that it is in negative cash flow. After obtaining the PCF value, this equation is used to calculate the IRR, and by assuming NPF equals to 0, we can calculate that the IRR that we get is 36.02%, and therefore since it is higher than the bank interest rate, this project is feasible. Lastly, the payback period is calculated by adding the PCF value as the cumulative cash flow, and then it is observed that the negative cash flow turns into positive at between the year of 1 and 2. Therefore, we can use interpolation to calculate the actual payback period, and also it is also plotted in the graph and can be justified that the payback period is 1.69 years.
Next, let's take a look at the sustainability consideration. Sustainability factors. Let's take a look on the environmental sustainability. Based on environmental sustainability factors, the straw filter is easily recyclable because the material that used for the shell of the straw is polypropylene and ABS plastic, which both of these materials can easily be recyclable. And next, it can help to reduce one of the main pollution factor, which is the accumulation of the plastic bottle usage. Other than that, the product also can be reusable for a long time, as the only maintenance that need for these devices is to clean the filter medium, or after a few years, then it can be thrown away. Last but not least, it can also help to reduce the plastic bottle accumulation. Next, based on the economical sustainability factor. First, the material used for these devices are very cheap yet still safe to be used, such as the polypropylene and the ABS plastic. It also, as the material that used for these devices is cheap, so the devices itself can be affordable and cheap. Last but not least, it can reduce the need to buy the plastic drinking bottle. Based on the social sustainability factors, our product helps our consumer to acquire clean water no matter the condition or situation. It also can be a devices for the group that cannot afford a proper sources of clean water. In addition, it also is a stepping stone of improving the experience of the adventurers and the explorers. Sustainable Development Goals. Two main Sustainable Development Goals agenda that we choose for our product is Goal 12, which is the influencing a responsible consumption and production, and Goal 6, which improve clean water and sanitation. Let's go through the first agenda of our product, which is to influence a responsible consumption and production. To achieve economic growth and long-term development, we must drastically minimize our environmental footprint by altering how we create and use commodities and resources. Every minute, 1 million of plastic bottles are purchased throughout the world, and the alarming reality is that the number will increase by 20% by 2021. Worse, 90% of the plastic bottles aren't recycled and wind up on landfill all around the world, where they lie for 1,000 years before biodegrading. Plastic bottles that do not wind up in landfills pollute our seas, harm our ecosystem, kill or injure marine wildlife. As a hiker or traveler, drinking water will be the most important sources of energy and to keep them hydrated to maintain their stamina throughout their activity. It also a lot of work to bring every clean drinking water for their journey of expedition, and also the accumulation of plastic drinking water bottle could harm our environment. With our product, we can avoid the increasing of consumption of plastic bottle, which has been one of the factors of the pollution in our environment, by having a portable device that can help the traveler get clean and yet safe drinking water. Let's take a look at the next agenda that we choose for our product, which is to improve clean water and sanitation. This agenda has certain target to attain before 2030. One of the target is to achieve universal and equitable access to safe and affordable drinking water for all. For most multi-day hiking journeys, the capacity to filter water is essential. Most lengthy wilderness treks are only feasible because you can transform any natural water source you come across, like rivers, lakes, into clean and safe drinking water. Otherwise, drinking water stocks need to be bring on their own, and despite the fact that a decent water filtration system is an essential element of camping equipment, selecting the proper one may be challenging. Clean drinking water is very important to give us the mineral needs needed for the body to function properly. Unfiltered water sources could contain various dangerous contaminants such as protozoa, bacteria, and viruses, which could affect the human health. Therefore, with our product, we can promote the availability of clean and safe drinking water for the adventurer no matter their environment, which is one of the targets to be attained in the agenda. Our product is aimed to be able to filter all kinds of contaminants that might give negative effect towards human body. Lastly is the sustainability in market. To stay in the market demand, our product need to be evolving based on the capacity to filter the contaminants. As the quality of the water source is changing over time, our product also need to change the ability to filter different types of contaminants. Last but not least, our product also need to be affordable and available for every group of people, and also at the same time safe to be used. Thanks for watching. Please leave a comment below so that we can improve our product in the future.